All right, so we're going to start talking about ions. So we're going to talk about bonding, and we're going to talk about ions first. So first off, this is a picture of pyrite, sometimes called iron pyrite because there's iron in it, but it's called fool's gold. It looks like gold, but it's not gold. But iron pyrite itself, and this is the chemical formula, is an example of what we would call a crystalline solid. So it's a solid that's made out of crystals. Um, so we're going to talk about valence electrons, and we've already previously done this. So the good news is we can answer this question probably pretty easy. How do you find the number of valence electrons in an atom of a representative element? So to review, valence electrons are the electrons in the highest occupied energy level of an atom. The number of valence electrons determines the properties of the element. That's why all the group 1 elements act one way and group 2 act a little bit different. To find the number of valence electrons, we just look at the representative number. So group 1A have 1 valence electron, group 4A have 4 noble gases, and this is, we've talked about this, helium has 2, all the others have 8. The valence electrons are what do all the bonding. So when we talk about bonding here, these next couple of videos, that's what we're going to be dealing with, the valence electrons. So as a general rule, only valence electrons are shown in electron dot structures. So electron dot structures are just diagrams that show the valence electrons. And we'll give you a couple of examples here. You can remember group 1A has 1 valence electron, so they have 1 dot. Group 2A has 2 valence electrons, 2 dot, and you can see boron and carbon and so forth. The halogens over here in group 7A, fluorine, chlorine, bromine, you can see have 7, so they're 1 short of 8, which is what we see right here with the noble gases. All numbers in a given group, except of course helium, have the same number of dots in their structures. So these are just electron dot structures, and it's just the valence electrons. So there's something called the Octet Rule, and noble gases, neon, argon, and down, are non-reactive because they are stable. And this was kind of figured out by Gilbert Lewis, who was a chemist, and he decided to give this rule and call it the Octet Rule, to why certain elements do not react. And what it means is that in forming compounds, atoms tend to achieve the electron configuration of a noble gas. So atoms want to be like a noble gas so that they can bond. An octet is a set of 8, octagon, octopus, etc. Oct means 8. Atoms of each of the noble gases have 8 electrons in their highest occupied energy level. So right here, you can see in these is that S2P6, which is 8 electrons in the valence shell. Atoms of metals lose valence electrons, so the ones on the left-hand side lose valence electrons. Atoms of the non-metals, so those on the right-hand side of the periodic table, tend to gain electrons, or they will share electrons, which we'll get to down the road. But again, their goal is to achieve an octet. So electron dot structure of bismuth, you look up Bi in the periodic table, and when you look for Bi, you find it, and then you draw dots for each of the electrons, and Bi has 5 valence electrons. So how we do valence electrons, it's similar, or how we do dot structures is similar to how we do when we fill out orbital diagrams. We go 1, 1, 1, 1, and then we pair up. But you don't want to pair until you have 1 on each side. That's just general. I doubt you'll get counted off by a college professor for doing it differently, but this is how we're going to do it, and I'll explain why as we go on with bonding. So what's a cation and how is it formed? So an atom is electrically neutral because it has equal numbers of protons and electrons, and we talked about that previously. An ion forms when an atom or a group of atoms loses or gains electrons. So the only way to make an ion is to gain or lose electrons. Protons always stay the same, okay? So a positively charged ion, or cation, is produced when an atom loses 1 or more valence electrons. So when it loses electrons, it becomes a cation. So a sodium ion forms when a sodium cation. So sodium loses 1 electron to become Na. A calcium atom forms a calcium cation, which is Ca. It should be 2 positive here, but it loses 2 valence electrons to get there. The most common cations are those with a loss of valence electrons from metal atoms. Most of these atoms have 1 to 3 valence electrons, which are easily removed. So sodium, for example, here's the electron configuration. Here's its valence electron. It removes that valence electron. It now has an octet because it has 8 electrons in the S&P for the second energy level. So by doing that, by losing an electron, it becomes a positive 1 charge. We can also see it with an orbital diagram. Here's the 3s orbital, right? That 1 electron loses, it becomes empty, and it looks like this, which is just like neon. So it takes the noble gas configuration or orbital diagram of neon, and in doing so, looks the same, but it has a positive charge because it will have 1 more proton than it does electrons. Magnesium is a group 2A. So magnesium has 2 valence electrons. There's the dot structure. A magnesium atom obtains the electron configuration of neon by losing both of those to become a positive 2 ion. So it loses 2 electrons, becomes positive 2. Here we have group 1A, group 2A, and you can see the atoms that are the ions that they form. So group 1A always forms positive 1 ions. You may want to write that on your periodic table somewhere, this group, positive 1. 2A, the alkaline earth metals right here, all form positive 2 ions. You may want to write that down somewhere because that'll be important. Positive 1, positive 2. Now, transition metals, cations, they will vary. So iron can be positive 2, or it can be positive 3. It can lose 2 valence electrons or lose 3. So it varies. So we really don't know, or there's no general rule when we talk about transition metals. Now, some ions with transition metals do have things that work, right? Silver, for example, has this, which means silver is a positive 1 charge. Okay. So not all of them are varied, but we'll talk about the ones that are in class. We'll talk about the ones that are common. So transition metal cations right here. Again, copper has one of these 4s. It drops the 4s to become a positive 1 charge, but it can drop more. It can become a positive 2 charge also. Iron pyrite, the fool's gold that we talked about previously, is iron with a positive 2 charge. Okay, and then it has sulfur here. So so we're going to write the electron configuration for iron. So here's iron, and it drops these 2, right, and it becomes this, which will make it this noble gas, or this octet, on its third energy level with the S&P, and that's why we say it has an octet also. Cesium atom form a cation. So we find cesium on the periodic table, make your prediction, and the answer, of course, is it loses an electron. So it becomes a cation by losing an electron, and that means it's in group 1A. So how are anions formed? An anion is formed when it gains 1 or more valence electrons. An anion does not keep the same name. In fact, we drop the end, the IE or whatever is at the end, and we put ide. So chlorine atom becomes chloride anion. Oxygen atom becomes oxide anion. And you'll have to get used to how that's done. Spelling will give you a break a little bit, but as you do it and see it, you'll be able to start to figure them out. And we talk about groups. Group 5 nitrogen, these are -3 ions. These here at the oxygen group are -2, and then the halogens are all -1 ions. You may want to mark that on your periodic table. -3, -2, -1. Atoms of nonmetallic elements attain noble gas electron configurations more easily by gaining electrons and losing them because they are almost at the octet. They just gain electrons to get to the octet, as opposed to the metals who lose electrons to get to the octet. Chlorine has 7 valence electrons. So here we go. So this is chlorine's electron configuration. By adding 1 electron, it gets its octet. So it becomes a -1 charge by gaining an electron. So here's chlorine again. We get an electron, and it makes it look just like argon. So now it gets the octet, and it looks like argon. So it gains a noble gas. We call chlorine and the halogens, they call them halide ions. You may see this come up a bit. But all halide ions have a -1 charge. Again, all the halogens are -1 because they're group 7. They have 7 valence electrons. They gain 1 to get to 8, and they're happy. Oxygen here, oxygen has the 6 valence electrons, and it gains 2 electrons to look like neons, so it gets its octet this way, which makes it -2 because it gains 2 valence electrons. Here are some common anions. You can get those from the periodic table by setting up the groups. Electron configuration for sulfide, and what noble gas shares this configuration. So sulfur electron configuration, the sulfide ion is this, which is just like argon, because sulfur is 3p4. It gains 2 electrons to be like argon. All right, so key concepts: to find the number of valence electrons, look at the representative elements. Positively charged ion is when an atom loses 1 or more valence electrons, also called a cation. An anion is when an atom gains 1 or more valence electrons, also called an anion. Valence electron, outermost energy level electron. Electron dot structure, it shows the dots as the valence electrons around an atom. Octet rule means atoms will try to gain or lose electrons to be stable like a noble gas, which is usually 8 valence electrons, hence the name octet. And a halide ion is a negative ion formed when a halogen atom gains an electron. Bonding and interactions: atoms form positive ions and lose valence, or form positive ions by losing valence electrons, and they form anions by gaining valence electrons. That is all.